Okay, so we get this y equals plus or minus square root x squared minus c. So where c is some positive. Now, if that was a perfect square, no, that'd be difference of squares. Okay. So let's put this in our calculator and see what do we get. Okay. So you know what? I'm gonna leave these. All right. So if I had the square root, now the numerator is x squared minus, let's say when x is 1, for instance, like we were doing before, divided by 3. So that closes off the square root. And then we'll do the negative. Negative square root. The numerator is x squared minus 1 divided by 3. Okay. So we have the plus or minus of our result. So let's just look and see what this does for us. Okay, so another absolute value makes sense, but it's not quite an absolute value. It's that's fine. That goes out in front. So for me, because I see it's x squared and we take the square root, then I know it's degree 1, but I'm thinking, okay, it's like an absolute value, but like if we think about transformations, we moved it, I guess that would be what, down c unit, so down 1. So right, so like it's almost like we have an absolute value, the same one we had before, but like the top half moved down 1, but we don't see it because we can't take the square root of a negative. So anything that was negative, we're not considering. And then we take the inverse of that function. So this makes sense to me. So then like when we do 2, it should be the same graph, but instead of having that the intercepts of 1 and negative 1, it should go to 2 and negative 2. So it's like we're moving, it's like the top absolute value is coming down each, whatever that c is that we're incorporating, and then we're reflecting about the x-axis. So it's seeming like we're getting, so what I'm seeing, let me just confirm when I plug in 2 instead of 1. So that was when our c was 1. Let's look and see what happens when our c is 2, for instance. I didn't mean to do that. Oh, come on. There we go. So then when our c is 2, let's just see what happens. And I should have the plus or minus 2. Oh, not quite, it looks like. Let's go to. Oh, that got changed from positive to negative. Let's see what happens there. So it didn't necessarily go through our plus or minus 2. But it is doing something similar to what we anticipated. So it looks like our contour lines, in this case, so when C is positive, it's looking like we're getting something, the following effect. So we have that and this, for instance. So then, the first one we got something that was like this and like this. Okay, then when we had 2, so it wasn't quite all the way to 2, but it's still something similar. So I'm just doing a rough sketch, like there, and there, and there, and there. And so 3, I would imagine, will continue in that fashion. Let me just do one more. So if the C were 3, for instance, 3 and 3, let's look at that graph. Yeah, so, oh, is it a curve on it? Oh, it is curving, okay. So now, it's kind of going like that. Let's go here. So we should probably do some more. But you know, it's a parabola, and let's look at some more. Let's do like when it's 4. Okay. So it is starting to curve, but you know, so you would imagine when it goes out, it have more and more curve to it. So that's when C is positive. So we're kind of getting a graph like this. And then when C is negative, so C strictly less than 0. So let's see what happens when we do that. Okay. Just in an attempt to generalize. So then we'll have x squared minus 3y squared equals a C. Again, this is some negative value. So I'm tempted to do the same thing as before. So if I solve for my y, so we should get the same thing. We'll get y equals plus or minus, it's going to be x squared minus c over 3 square root. Now notice, because the c is negative, that we're actually adding a positive. So it means that the inside will always be positive, which means, you know, every x should work. But let's just get a sense of, let's get an idea of what's going on here. So now, for instance, instead of -4, that would be +4, and this would be +4. Let's see what that does to our graph. Okay, so you can see the smooth curve. The positive was the top, the negative was the bottom. So then this one, okay, and then you can probably get an idea of what's going to happen. So if that's 4, then if this was like +3, and this was +3, I think we have a sense of what these varying values of z are going to do for us. Let's look at the graph. So again, it's still the curve. Okay. So when the c is negative, what we ended up getting. This is a quick sketch. So it's behaving kind of like. So we're getting something like this and like that. And then I think it's just kind of going more and more like this and like that. And then, you know, like that and like that. You know, this is a rough sketch or a quick sketch. So when C is 0, we get the two absolute values that are reflected on top of each other. And then when C is positive, we're getting, let me see what it's called. So this confirms what they had. So it's above there. So the hyperbola, yeah. So yeah, so you can really see it here. So when C was 0, we had x equals plus or minus the square root of 3 times y. You know, basically it's like, what do we get? C was 0. Yeah. It's like an absolute value, two absolute values there.